Good day everyone, my name is Dan Ivan Castillo together with my groupmates. Welcome to our Quaranphysics vlog. So, for today's vlog, we will be discussing one of the Isaac Newton's famous discoveries, which is the laws of motion. But before we jump into that topic, let's all give a little background about this famous physicist and mathematician, Isaac Newton. Just like what I said earlier, Isaac Newton is a famous English mathematician, physicist, astronomer, alchemist, theologian, and author that is widely recognized as one of the greatest mathematicians and physicists of all time. One of his famous discoveries is the Newton's laws of motion. That is the topic that we are going to discuss for today. So, Newton's law of motion set the foundation for modern classical mechanics. So, it can be applied in anything, especially that it is about motion. So, now, according to Isaac Newton, there are three laws of motion. So, the first law of motion is the law of inertia. The second law of motion is the law of acceleration. And the third law of motion is the law of action-reaction. So let's all chop up these three and discuss it one by one. So the first law of motion, which is the law of inertia. So this law simply states that if an object is at rest, then it will remain at rest, unless there is a force or an unbalanced force acted upon it. And if an object is in a constant speed in a straight line, then it will remain at motion unless there is an unbalanced force acted upon it. The first law is self-explanatory. That simply means that if an object is not moving, then it will not move. On the other hand, if an object is currently moving, then it will remain in that constant speed unless there is something on its path that could make it stop. So here are the two real-life examples of law of inertia. Let's watch this.
This bike is currently leaning on the wall. As you observe, you can see that this bike is not moving because I am not applying any force in it. And now, I'll pedal this bike. You can see that I am using the pedal for the entire bike to move in a certain velocity. This is an example of law of inertia. The bike will stay at rest unless I applied a force in it.
The second example of our law of inertia is called paper, a cup, and a coin. So as you can see, we have a paper, a glass, and a coin. Above the glass, we have a paper and a coin. Let's see what will happen next after we pull the paper above the glass. As you can see, the coin has fallen down to the bottom of the glass because the coin has enough inertia to resist moving with a piece of paper, but the gravity acts upon it and it falls to the bottom of the cup.
Acceleration is directly proportional to the force applied and inversely proportional to the mass of an object. It is expressed as acceleration is equal to the force applied over the mass. We said that acceleration is directly proportional to the force applied, which implies that an object acceleration is determined by the force given to the body. If the force is more, the object will accelerate more, and if the force is less, the object will accelerate less.
Today I'm gonna show you what will accelerate faster, a larger ball or a smaller ball. I'm going to exert the same force for the two balls, and let's see who will accelerate faster. Since the smaller ball is lighter than the large one, we have to apply much force in it for the ball to accelerate.
Hello guys, this is the first example of law of acceleration. As you can see in the video, we have two different containers. It is both full with clothes and it has wheels. Now, pushing and pulling the first container is easier because the mass of it is much lower than the bigger one. Since the bigger one has more mass, you need to use more force than the first one. That's it guys, thank you!
Yay! We are now down to the last law of motion, which is the third law of motion. The third law of motion is the law of action-reaction. So this is famously stated as follows. For every action, there is an equal and opposite reaction. Well, this is often quoted out of context for metaphorical purposes. In physics, it means something specific and quantitative. So it means that if two objects interact, the forces they impart to each other will be equal in magnitude and opposite in direction. So
When I want to move toward the table, I use my arms to pull the table. The reaction is I move forward the opposite direction of my pulling. So when I want to move away from the table, I also use my arms. I push the table to the direction of force is forward. That is the action. The reaction is I move backward because the table exerts force to me.
And finally, we are now finished on discussing the three laws of motion in accordance to Sir Isaac Newton. But before we end this video, we will be giving you a 3-item quiz wherein you will just choose the correct answer. We will be giving options for you to make it easy. So the first one, according to Newton's first law of motion, a object or a moving object that is not acted on by an unbalanced force will A. Remain in motion, B. Change its momentum, C. Eventually come to a stop, or D. Accelerate. And you got it right! So the correct answer is letter A. So A, it will remain in motion. Let's all move on to our second question. So this is a situation. A person is pushed forward into their seatbelt when a car suddenly stops. Which of Newton's laws explains this motion? A. First law, B. Second and third laws, C. Second law, or D. Third law. And you got it right. So this situation is included on Newton's first law of motion. And let's move on to our last question. Newton's third law is often called as A. Newton's second law, B. Law of equality, C. Law of action-reaction, or D. Law of inertia. Job well done! So the correct answer is letter C, action-reaction law. And sadly, we are now going to end our vlog, and we are hoping that we would see you soon again, and we are very excited to meet you all soon. And this is our Quaranphysics vlog. My name is Dan Ivan Castillo, again together with my groupmates. Thank you guys for watching, and goodbye.